What we're going to do today is we're going to look at a controls chart where instead of tracking means and ranges and whatnot, we are going to develop what's called a P chart. And that is what's tracking the percentage of things that we have defective. And those things could be parts, they can be complaints, they can just be anything, but it's the percent that is defective. And so that is a P chart. So the other ones we've done are the X bar and the R charts, so we're going to look at a P chart. So we're looking at this, and we've got clerks at this data entry system. They enter thousands of insurance records each day for the different clients, and the CEO wants to set control limits to include 99.73% of the random variation in the data entry process when it's in control. So that 99.73, that is, once again, that falls down to our standard normal curve. That would be a z-value of 3. So let us go and look at our model. So what we have is we have a sample size of 100. And so every time they sample this over the 20 times, they're going to be sampling 100 different data sets, the key entries, and figure out how many of those are incorrect. So we have a confidence interval of 99.73, and so we know that's a z-value of 3. Right from our standard normal chart. And so from there, what we're going to do is we're going to calculate out percentage errors. And so the first thing that we want to do is we want to calculate out the mean fraction. So basically look at all of our samples and figure out how many from all of our sample sets are defective by percentage. So what we're going to have to do is first we're going to have to just figure out what our pure number of errors are. So we're just going to sum up all of the errors from our 20 sample sets. So we found 80 errors across the 20 sample sets, and with 100 per sample, that is going to be 80 errors out of 2,000 data points. So let's go and do that then. So we're going to have, so the fraction is going to be the number of errors, and then we're going to divide that by the number of samples taken across all sample sets. Now we could just do, well, we know we've got 20, we're going to multiply it by 100, but once again, we don't want to bury numbers in, we want to automate this as much as possible, so we can make this a little bit more complex than we need to. And so we're going to take the sample size, and then we will multiply it by the count of all of our samples. And so count's going to sit there and go, okay, there's 20 of them there. I have one too many parentheses. It's going to take the count, there's 20 of them there, and then it's going to multiply it by our sample number. And once again, this sets us up to be able to use this sheet again just by starting to change items. And so if we hit that, our mean fraction is 0.04. which means that that is 4%. So we put it into percentages. So we have a 4% error rate on this. Okay, and so that's our mean fraction. This is also going to be, we'll refer to it as P bar because P is that percentage of errors and bar just means mean. So the next thing that we want to do is we want to calculate out the standard deviation of this population. So we're going to go back to our notes in business statistics, and actually we can also look at the notes in our book now. And so we have, what is that equation for the standard deviation of a population when we're dealing with percentages? Well, it's going to be that mean fraction, that P bar, times 1 minus P bar, and then we're going to divide it by the sample size, and then take the square root of that entire thing. So square root, and we will need an extra parentheses there, of P bar times 1 minus P bar. And we take that as a numerator and we divide it by our sample size. And so we have a standard deviation of 0.0195. Okay, and from there now, we just have to calculate out what our upper and lower control limits are. How do we solve that? As we saw in the text, it's going to be that mean fraction plus or minus the z value times the standard deviation. So we're just going to come in here and go, okay, well, my upper control limit will be plus, so that's the mean fraction plus the standard deviation times the z value. And so this, because I have mean fraction and percentage, this defaulted to percentage. So let's change this back to just a number. 3 decimal points. I'll change this back to a number 2 then. And so now what we need to do is we need to take a look at the lower control limit. Now, since I did not put range names in, this is not going to work out by just dragging it down, so we'll have to type it again. So equals standard deviation, oh, not standard deviation, mean fraction minus standard deviation times the z value. Oh, this is a problem. We have a negative fraction rate. That means that we've actually created more good samples than we actually had. Therefore, we have to tweak this equation a little bit, because this can happen sometimes when you're looking at the lower control limits of stuff, because really it comes down to 0 is as low as you can go with all these things. So typically what we can do is we can just add in our max function and go max, and give me the maximum of this or that. And there we go. That gives us a 0. And let's just say, if I put this at 1, you can see that, okay, well, my lower control limit's above 0, so therefore I will actually put that number in. But we are at 3. So we'll go back to there. This is at 0. Everything's good. So we have our upper and our lower control limit. Now let's actually look to see. Let's go to see if it's in control, if there's any problems. So at this point, since I am going to drag that stuff down, let's actually move the mean fraction over here. Let's actually call it p bar. And so I'm just, by physically moving the cells like this, by just clicking and dragging, it preserves any of the relationships, so it's a lot better than just copy and pasting. So the equations will drag around. It's a useful thing. And so we're just going to range name these just to make it a little bit easier. So we're going to go into formulas, create from selection, left column. And here, let's be really technically correct. Let's actually put our range names over there. Control B to bold that. Use in formula, paste names, paste list, and there we go. All right. So P bar is going to be equals, my P bar is 0.04. My upper control limit based on the percentage of errors, so UCLP, and then LCLP. And so now I'm just putting these down. I'm just going to drag them down so I have data points to refer to when I go and I make my graph in Excel. All right, so we've got our sample number. Control actually let me grab the titles in there. Control, select our fraction defective, and actually, since they're all right next to each other, control and select it this way. Okay, so once we have the data selected, we're leaving out error number because it's not important for the graph. We're going to insert, we're going to go to our friendly XY scatter chart, and we'll just drop in points right now because we'll change that. And then we're going to move chart to a new sheet to make things a little bit easier for us. And so we are going to call this, we'll leave that there. We'll put the chart title up here for this one. So, and just P chart. Okay, and let's add some axis titles before we clean up the dots. So this axis title is going to be, this is our percent defective. And down here, this is our sample number. Let's see, let's change this axis up a little bit. Format axis. We only go to 20 samples, so we'll start with 1. We'll go right to 20 just to maximize our area. Over here, percent defective, excuse me. Let's go over here. Let's go into our text options. Oh, wait a second. Is it axis options? Ah, yes, number. So when we go to number, we're going to change this to percentage. And we're going to lose all the decimal places because we don't need them. And so there we go. And then we'll right click on here, change chart type. Let's go to our combo chart and fraction defective. This time, let's actually have the line in there. So we'll do markers with straight lines, P-bar, and everything else. We're just going to make a straight line. It really doesn't matter which of these two that we have because it'll give us the same thing because they're both perfectly straight lines. And then let's get rid of this secondary axis. And once again, because it defaulted to secondary axis, it kind of messed up our thing here. So I always forget to wait to change that, but that's okay. So we'll put that there. And then once again, I'll just make these. We'll make these dotted line, or gray lines, and then a dotted line for our mean. So I like using that little blue-gray there. And then we'll come back here, and we're just going to make this a dotted line. And we'll use the big dashes. Okay, so now as we take a look at this, and we start to look at whether or not the process is in control, you can see that we do have a point that is outside of the control. So there is something to take a look at. Something's kind of funny. The rest of these data points are pretty good. There's no huge trends going up. I mean, we started to see one. We've got 4 points here going down, but then it changes. So there's probably nothing to worry about here. But this is the big problem because it is outside of our control limits. And there we go. So this is how we would create a P-chart. This is how would we look at it. And I use the line here because, especially this one, the little data points that we've done in the ones before, that is fine. But especially when you start getting a lot of points, it's actually a lot easier to read with the straight lines in there. But I still like showing these data points off so we can see exactly where we're taking the data. And so with that, that's what I've got for you in this video. If you have any questions, please let me know. Otherwise, I will see you in the next video.